pero simple harmonic motion na siya. Kanina constant velocity lang, so straight diagonal line lang. Pero ngayon, gagamit na tayo ng semicircle.
Then
Yung dwell niya, from 30 degrees, ginawang 60 degrees.
outstroke dwell is 60 degree. Return stroke is 120.
Kaya yung kanyang return stroke is constant velocity o uniform velocity. So, pwedeng maghalo yun. Pwedeng sa outstroke, iba yung motion dun sa return stroke. So, dito sa uniform velocity, again, straight line lang to. Diagonal pababa.
Degree with uniform velocity and dwell for the remaining period of cam rotation. Lift of the follower or stroke of the follower is 30 mm and least or minimum radius of the cam is 5 centimeter, and we are assuming that the cam rotates in clockwise direction. So for this specification we have to draw the cam profile. Now first we'll see how to draw the displacement diagram in this particular case, then we'll actually construct it, and then we'll see the with the help of animation how to actually construct it so that you can easily understand the given procedure.
Ito na yung final outcome. So, makikita nyo dito, ang ginamit na scale is yun pa din. Sa 1 cm is 20 degrees. Then, hinati sa 6 yung outstroke. Hinati sa 6 yung return stroke. Then, sa outstroke, gumamit ng simple harmonic motion. Kaya naglagay ng semicircle dito sa left side. So, yan yung scale
So
natin.
here we have taken the space diagram scale. So on x-axis 1 centimeter is 20 degree of the cam rotation. So you can see over here the outstroke, as we have seen, it is 120. So 120 divided by this 20, so it is 6 centimeter. So this particular length will be of 6 centimeter, and we have divided that into, suppose say, 6 equal part. Then the next is outstroke dwell, that is 60 degrees. So 60 again divided by this 20, that is the 3 centimeter. So this length will be for 3 centimeter, as you can see here. Similarly, this return stroke is of 120 degree. So it is 120 divided by this 20, that is 6 centimeter. Then as this outstroke is with simple harmonic motion, we have constructed this semicircle over here, and we have divided it into 6 equal part. Now from point 1 draw the horizontal line, from point 2 also draw the horizontal line so that it will intersect this second line over here. From point 3 draw the horizontal line so that it can intersect over here at this particular point, and name those particular parts. So as you can see over here, the horizontal line which we have drawn from 1 will intersect this our line from the first point at point A. Similarly, this horizontal line will intersect this particular vertical line at point B, and so on. And then draw a smooth curve that is passing through these particular points. Then there is a dwell period, so it will remain at this particular position for 60 degree of rotation. Then the return stroke is of uniform velocity, so join this diagonal like this, and these are the points, that is F, G, H, I, J, K. These are the distances which are important for us. So all these distances, that is 1A, 2B, then this 3C, 4D, all these distances are important for us, not only for this outstroke but also for the return stroke. Now we'll see this particular construction with the help of animation. One more thing, that on y-axis we are having the scale as 1 centimeter is equal to 1 centimeter of the lift of the follower. Our lift of the follower is 30 mm, that is 3 centimeter. So this vertical distance will be of 3 centimeter. Now let us see how to construct this particular displacement diagram. We'll see the entire construction also afterwards in full animation form. So as explained earlier, we are drawing this displacement diagram, dividing the semicircle, then drawing the vertical lines, then horizontal lines from the given particular part, and then a smooth curve passing through those intersection points of A, B, C, etc. Similarly, in case of the return stroke also, we'll get this type of the construction. This we have already seen. Now let us see how to draw actually this particular cam profile. Now we know that the least radius of the cam is 5 centimeters. So we have drawn this circle of 5 centimeter. Then outstroke is 120 degree. Divide this circle into 6 equal part as shown over here during the outstroke. Then there is a dwell period. Then again divide the return stroke into 6 equal parts and draw these lines passing through this. Now, as you can see over here, these are the distances which we have measured, correct? 0.75, 1.5, 0.25. Those we are transferring over here on these lines. And then we are drawing a smooth curve passing through these particular points. So this is for the outstroke. Then there is a dwell period. From this to this, there is a dwell period. Similar to this 3 centimeter, 2.5 centimeter, 2 and 1.5. Those points, they are also plotted over here, and we have drawn a smooth curve, that is this particular green curve passing through those particular points. So this blue line represents the, what we can say, outstroke. Then there is a outstroke dwell, and then there is a return stroke. So all these distances, that is 3 centimeter, 2.5 centimeter, 2, 1.5, 1.5, these are all transferred over here. So this is 3, 2.5, then 2, 1.5, 1.5, etc. for this return stroke. Similarly, for this outstroke also, we have transferred all these distances over here. Now, we'll see how actually we'll draw this particular diagram. So let us start with our actual drawing of the cam profile. So as the outstroke is of 120 degree, divide it into 6 equal parts. So we are dividing this outstroke of 120 into 6 equal parts. Then there is a dwell for 60 degree. Again, divide the return stroke into 6 equal parts. Now we'll draw the displacement diagram also simultaneously over here, which we have already seen how to draw it and how to measure the distances, and those distances will transfer on these particular lines. First, we'll start with the outstroke, as you can see over here. So as the outstroke is with simple harmonic motion, we'll draw the semicircle, then divide that particular semicircle into 6 equal part. 180 divided by 6, so 30 degree angle we have taken, so that we can divide that circle into 6 equal parts. Then locate these particular points on our semicircle. And join this with the center. Now transfer these points on the corresponding lines, vertical lines which we have drawn, and draw a smooth curve, that is a simple harmonic motion. Now the points which we have marked on our circle, transfer the given particular distances, as you can see over here on those lines, and then draw a smooth curve passing through this particular point. So we are drawing these points of intersection with the line of this arc. So this is our cam profile during the outstroke. There is a dwell for the remaining degree. So we have just drawn a curve over here. Then the return stroke is with uniform velocity. Again, divide that particular return stroke of 120 divided by 20, that is 6 centimeter, into 6 equal part, and join this diagonal. And these distances, they are important for us, so we are marking this point so that we can transfer these distances as we have seen earlier on our this particular blue lines. So we are just marking the points on our circle. Now transfer these distances. Mark this point of intersection of this arc with these blue lines, and then draw the curve. So this is our complete cam profile. Thank you very much for watching.
Okay. So, ganito na yun. May humarang. Yan. Ganito na yung final output ng ating cam base dun sa curves na binibigay. So, yan. Nakakapag-design na tayo ng cam. Ba't pa natin nakakaralin yung analytical method? Ganun talaga eh. Okay, tatlo na lang to para lang mas marami tayong matutunan. Next.
In this video, we'll try to understand how to draw cam profile. Now we have to draw a cam profile in case of a knife edge follower using the following data. Minimum radius of the cam is 5 centimeter. Then outstroke is 120 degree with simple harmonic motion. Outward dwell is 60 degree. Return stroke is 120 degree with simple harmonic motion, and dwell for the remaining period of cam rotation. Stroke or lift of the follower is given as 6 centimeter. So the data is written over here. So outstroke is 120, outstroke dwell is 60 degree, return stroke is 120 degree, and remaining angle will be return dwell, that is 360 minus the summation of all these three particular angles. So it is 360 minus 120 plus 60 plus 120. So that will be nothing but 60 degree. Lift or stroke of the follower is given as 6 centimeter, and minimum radius of the cam is given as 5 centimeter. Now the important part is to select the scale over here. So scale that we have chosen, outstroke is equal to 120 degree. So it is 120 divided R as 6 centimeter, 3 centimeter equal to 1 centimeter length meter through this line from 3,
So dito,
and so on.
simple harmonic yung motion ng outstroke. Tapos dun sa return stroke
Now
ay
we have to join these particular
length.
points by smooth curve. So this is the this same points will be there
At ang gagawin dito,
for the
since parehong simple harmonic motion, hindi na tayo magagawa ng semicircle dun sa kabilang side. So dito, pwedeng, kumbaga parang AutoCAD, imi-mirror na lang natin yung points dito sa kabilang side, sa return stroke.
return stroke also.
I-trace nyo na lang din. Yan.
And then join a smooth curve from this particular point. So this is the curve for
As
return
once nabuo na yung curve, at titrace na lang ulit siya dun sa ating base circle.
stroke. And then this is the dwell. So we have completed this over the displacement diagram in case of this particular problem.
Pwede kayong kumain na. Alas 12 na guys. Huwag nyo ang isipin nagtitiis ako ng gutom para sa inyo. Alam nyo na yun kahit di nyo na isipin.
Now we draw the cam of 5 base circle of 5 centimeter radius, and then we'll divide, taking this particular vertical line as a reference. We'll divide the given particular base circle in 6 equal parts of 20 degree for our outstroke, because our outstroke is of 120 degree. So 120 divided by 6, that is 20 degree. So these are the lines which we have drawn of 20 degree from the center of this particular circle. Then remaining 60 degree is for dwell. So from 120 to 180, correct? Or this is the 60 degree angle which we have drawn over here. Then we'll draw the lines for the returns to, which is also of 120 degree. So these are the lines which we have drawn for returns to. So it is from this 0 to 6, these are the parts for our outstroke. Then this is the 12, and this is our 6 to 12, these are the return stroke part. So as we know that this particular is theta O, then 12, and then there is a return stroke. Now we'll transfer this 1A distance over here on this 1A, then this 2B distance from 2 to B over here on this line, then from 3 to C it will be on this particular line, and so on. So first we'll measure this particular distance. As you can see, we have measured this distance. So we have drawn this line over here. So this particular distance we have to mark over here. So we'll be marking that particular point. So it is 1A distance is marked over here. 1A distance is marked. Similarly, we'll now draw or we'll mark this distance 2B over here. So this is 2B distance as indicated by this dark line and this 0. So that we are marking over here. So this is 2B distance. This 2B distance is marked over here. Similarly, this 3 and C distance, that is 3 centimeter, that we are marking over here, that is 3C distance. Similarly, for 4D, then for 5D, and then for this particular 6F. Similarly, this 6F will be drawn on the return stroke lines also. So all these particular points are drawn. So it is 6F, then 7G, 8H. So all these lines 6F, 7G, 8H, these distances that are transferred over here on the corresponding lines. Now we have to draw a smooth curve passing through this particular points, and that will be our cam profile. So as you can see over here, this is the curve cam profile that we have drawn. This is the dwell period, and so this from 0 to 6 it is the outstroke. Then there is a dwell from F to F, and then from F to this particular L part. Correct? It is nothing but what the dwell, and then it is nothing but the return stroke, and then there will be a dwell period of 60 degree. So that will complete our complete cam profile. So in this way, we can draw a cam profile in case of this particular knife edge follower having simple harmonic motion during outstroke as well as during the return stroke. Thank you very much for watching.
Okay, so magkaroon naman tayo ng bagong something.
In this video, we'll see how to.
Dito naman is, ang follower is oscillating. So, ito mahirap to. Kasi kanina, yung mga followers na pinanood natin, ang motion lang niya is up and down lang siya. Reciprocating up and down lang. So, dito sa oscillating, naka-fixed yung ating followers sa isang dulo, kaya ang motion niya is nag-arc siya.
To draw cam profile in case of oscillating roller follower. So let us start with the problem statement. So we have to draw a cam profile to drive an oscillating roller follower with the following specifications. Follower to move outward through an angular displacement of 20 degree during the first 120 degree of cam rotation. Follower to return to its initial position during next 120 degree of cam rotation. Follower to dwell for the rest of 120 degree of cam rotation. The distance between the pivot center and roller center is 120 mm. Then distance between pivot center and cam axis is 130 mm. Minimum radius of the cam is 40 mm. Then roller radius is 10 mm. Outstroke and instroke, both stroke takes place with simple harmonic motion. So using this data, we have to draw the cam profile. So as you can see over here, the oscillation is given as 20 degree. Oscillation of the follower is given as 20 degree. So convert that value into radian. So we have multiplied it by, so 20 into pi by 180, that is pi by 9 radian. Now A1A is the distance between the pivot center and roller center. So this is the A2 is the roller center and A1 is the pivot center, and that value, that distance is given as 120 mm. So this is our radius. Then arc AA2. Now we know that arc S is equal to r theta. So radius is 120 and theta is pi by 9. So this value comes out to be 41.887 or nearly 42 mm. Now this arc distance will approximately will be equal to this vertical distance. So we can say that the lift of the follower is 42 mm in case of drawing the displacement diagram. Now theta outstroke is given as 120 degree with simple harmonic motion. Return stroke is also 120 degree with simple harmonic motion. Then return dwell is also 120 degree. Minimum radius of the cam is 40 mm. Then radius of the roller is 10 mm. Therefore prime circle radius will be equal to 40 plus 10, that is 50 mm. Convert these values into in centimeter, so it is 5 centimeter. Now we'll take into consideration the scale, which is very very important. So on x-axis we are having a scale of 1 centimeter is equal to 20 degree of cam rotation, and on y-axis we will take 1 centimeter is equal to 10 mm of stroke or lift of the follower. So you can see 120 divided by 20, that is 6 centimeter. So theta outstroke will be 6 centimeter. Similarly, theta return stroke is also 120 divided by 20, that is 6 centimeter, and theta return dwell is also 120 divided by 20, that is 6 centimeter. So total will be 18 centimeter, out of which the outstroke and return stroke, they are important for us while drawing the displacement diagram. So first we'll mark the length of 18 centimeter, then divide the
Dito regardless kung anong type ng follower niya, mapapansin nyo, kanina may knife edge, may roller, tapos dito ay flat roller pa din naman. Yung pagkagawa ng cam displacement curve, pare-pareho lang.
outstroke and return stroke in 6 equal parts as shown over here. So as you can see, the lift of the follower is 42 mm. So the arc distance which we have approximately converted into the vertical displacement. Then outstroke is 120 degree, return stroke is 120 degree, and return dwell is also 120 degree, and all of them are 6 centimeter by scale, and we have divided that particular 6 centimeter into 6 equal part. Now as it is the motion is a simple harmonic motion, we will draw a semicircle of radius 42 divided by 2, that is 2.1. 42 divided by 2, that is 21, that is 2.1 centimeter. 21 mm, that is 2.1 centimeter. Now we have to divide this semicircle into 6 equal parts. So 180 divided by 6, that is 30 degree. So we'll draw lines of 30 degree as you can see, and then we'll mark these points. So you can see this is 0, 1, 2, 3, 4, 5 and 6. So we have divided this semicircle into 6 equal parts. Now we have to draw projection from point 1, 2, then 3, 4, 5, like that. So the projection drawn from 1 will intersect this one over here at this point. Similarly, it will intersect this 11th vertical line at this point. From 2 it will intersect over here at this point. Similarly, it will intersect the 10th point over here. Now as the motion is simple harmonic motion for both outstroke as well as return stroke, we have extended this point over here on the return side also. This third line, the third projection will intersect this vertical line at point 3, as well as it will also intersect this ninth vertical line from 9 at this particular point, and so on. So locate these points and draw a smooth curve passing through these particular points like this. So this is the rise and this is the return stroke. This is the outstroke motion with simple harmonic motion, then return motion during the return motion using the simple harmonic motion. Now for us these points A, B, C, D, E, F, G, H, I, J, K, these points, they are important. So first we'll measure distance 1A, 2B, 3C, 4D, 5E, 6F, then 7G, 8H, 9I, 10J and 11K distances. Now as you can see, 1A distance will be same as 11K, then 2B distance will be same as 10J, 3C will be same as 9I and so on. So let us measure those distances first. So 1A distance comes out to be approximately 0.3 centimeter, then 2b distance is 1 centimeter, 3c distance is 2.1 centimeter, then 4d 1 centimeter. So using these distances, now we have to draw the cam profile over here. So first we have to draw the base circle, which is of 4 centimeter. So minimum radius of the cam is given as 4 centimeter. So we have taken a radius of 4 centimeter, and then we have drawn base circle or minimum radius circle of the cam.
Ito yung mahirap na part. Ah, kasi pagka, again, pag oscillating follower, ay naka-fix yung ating isang point, isang end ng follower, tapos meron lang siyang arm, tapos nag-bounce lang up and down yung ating follower. So dito, naka-fix siya ang may given na 12 centimeters from the center line. So then, ang distance daw nung ating fixed point dun sa center nung cam is 13 centimeters. Kaya nabuo itong triangle na to. Itong nandito sa figure. So 12 centimeters to, layo sa center, then yung haba ng arm pala niya, 12 centimeters, then layo dun sa center is 13 centimeters. Kaya may nabuong triangle. Ngayon, gagawa tayo ng circle uli na malaki base dito sa 13 centimeters na to. Tapos, ipa-plot natin yung different positions niya. Again, kasi kung ilang hati yung ating angles, ganoon din kadaming hati. So kung hinatin natin ito sa 12, yung ating base circle, hahatiin din natin sa 12 itong ating outside circle. Tapos, kailangan natin ng compass dito. So, yung compass, since naka-fix naman sa 12 centimeter yung haba ng ating arm para sa oscillating follower, yung pointed type, yung pointed end ng compass, if tatama natin dun sa outside circle, then gagawa tayo ng arc dito sa ating mga nasa prime circle. Then kung gaano kahaba ito is, again, nakadepende dun sa ating cam displacement curve.
Then prime circle, add the roller radius 4 centimeter plus 1 centimeter. 1 centimeter is the roller radius, so 5 centimeter. This is the another circle, which is the prime circle, as we have already seen. Then the pivot circle, which is of 13 centimeter. So the distance between the cam axis and pivot center is 13 centimeter. So draw another circle which is of 13 centimeter radius as indicated in the diagram. Now we'll take this point as a center and we'll draw a roller of a radius of 1 centimeter. So we have drawn this roller which is of 1 centimeter length. Now we know that the distance between the pivot center and the roller center is 12 centimeter. So we have to choose the arc of 12 centimeter. We have to choose the radius of 12 centimeter, and then we have to draw an arc. So let us do that particular thing over here. So we'll take a radius of 12 centimeter and then we'll draw an arc, so that that particular arc will intersect this circle pivot 13 centimeter radius circle, correct, at certain point over here. So that is also shown in the procedure. So you can see this is the point. So this is the pivot center. So pivot center is joined over here with the roller center, and pivot center is now joined over here with the cam axis center or cam center. So this will complete our first part. Now we have to divide this particular circle, that is the pivot circle, into 6 equal parts. So 120 divided by 6, that is 20 degree. So these are all 20 degree angles, correct. So outstroke is also divided into 6 equal parts, and return stroke is also divided into 6 equal part of 20 degree, because outstroke is 120 and return stroke is also 120. So 120 divided by 6, that is 20. So this is 1 2 3 4 5 6 7 8 9 10 11 and 12 parts, inclusive of outstroke and return stroke. Now from this point 1, we have to draw arc of 12 centimeter on this prime circle. So that procedure will be shown over here. So as you can see, taking this as a center and radius is equal to 12 centimeter, we have to draw an arc of 12 centimeter on the prime circle. So this is the 12 centimeter radius point, and draw the arc as shown in the animation. So this is our first arc. Then taking point 2, draw another arc of the same centimeter, that is 12 centimeter. So that also we have shown over here. Then put this over here at the
Yeah, okay. So ito na yung sinasabi ko kanina. So, yung itong outer circle, i-compass natin yung different points niya papunta dun sa prime circle natin. Tapos, kung gaano kahaba yung nasukat sa cam displacement curve, ganoon kahaba yung i-project. Then, yung na-project natin yun na yung magiging center ng ating mga roller para matrace natin yung cam profile.
third part and then draw the arc and so on. So we have to go on marking these particular arcs from the respective points. So now it is the fourth point, and again draw the arc over here like this and so on. So you can easily understand this particular procedure, so that we are drawing the arc continuously from the respective points. Now on this particular arcs we have to mark the distances which we have noted down, that is the distances of 1a, 2b, 3c, 4d, 5e, 6f and so on. So all these distances we have to put on this particular arc. For example, 1a distance is 0.3 centimeter, correct, and another distance was 0.8 and so on. So all these distances will put over here. So after completing this, first we'll mark the distance of 0.3 over here on the first line. So as you can see, we have marked 1a over here. Then the distance of 0.8 on the another line, so that also we have marked over here. Then of nearly 1 centimeter, 1.1 centimeter, that distance also. Then of 2.1 centimeter. So all these distances are marked on this. Now using those points, that is 1a, 2b, with a as a center and taking roller radius, we have to draw the rollers over here like this. Then taking this b as a center, we have to draw circle like this. Then taking this c as a center, we have to draw the roller radius and so on. So you can go on drawing this radius. So this is, so once again this is 1a, 2b, 3c, 4d and the other distances. So we have marked all this, we have drawn this ruler from the respective points till the end. So let us now repeat this procedure in our next animation. So as we have discussed earlier, we have drawn the given particular rollers. So this is O, A1, A, correct? O is the cam center. This is the roller center. A1 is the pivot center. Then these are the 12 parts which we have made of 20 degree each for outstroke as well as for the return stroke. Then with 1 as center, arc distance is equal to A1, that is 12 centimeter. We have drawn the arcs over here, and then on this we have transferred the distances 1A, 2B, 3C, 4D, 5E, 6F, 7G, 8H, 9I, 10J, 11K and so on. With A as the center, we have drawn these rollers.
with B as a center, we have drawn the roller of 1 centimeter radius, and so on. And now we'll draw a smooth curve, and this is the cam profile. So in this way we can draw the cam profile in case of the oscillating roller follower. Thank you very much for watching.
Okay, analyze lang natin itong part na to. So again, review lang. Nagkaroon pa tayo ng isang malaking circle dito sa outside kasi ang follower natin is, ang tawag sa kanya is oscillating follower. So pag oscillating follower, nag-up and down pa din naman siya pero naka-arc siya. Then, naka-fix yung arm niya na 12 centimeters yung haba, given naman yon. Then, 13 centimeters na yung layo nung fixed point dun sa center. So, nagawa natin tong outside circle. Then, kung ilang parts natin hinati yung ating prime circle para sa ating pagpa-plot nung mga displacement, ganoon din kadaming parts natin hahatiin yung ating outside circle. Tapos, i-compass na lang natin from the points nung nahati natin sa tigti 20 degrees yan, papunta dun sa prime circle, yung pag-determine ng mga arc. Yan. Tapos, pag i-project na natin yung mga point, lalagyan uli natin sila ng rollers kasi roller follower to. Then yung rollers, itatangent uli natin yung wrench curve para matrace natin yung cam profile natin. Ito na yung ating cam. Ang last video, pagkatapos itong last video, tapos na tayo. Bukas na lang uli. Dito naman is paano pag-offset. Kasi kanina, lahat ng ating mga video, puro inline yung ating followers. So, paano naman pag-offset? So, para makita natin yung difference, ipapakita muna itong video na naka-inline, then ipapakita yung paano pag naka-offset. So, dito sa inline at offset, ganun lang din yung cam displacement curve niya. Pareho lang din. At para pa simple yung video, ginamit lang niya is constant velocity, kaya nakadiagonal lang siya.
In case of offset knife edge follower. So let us start with the problem statement over here. We have to draw a cam profile to operate the inline knife edge follower using following data. Outstroke with uniform velocity for 60 degree of cam rotation. There is no dwell period between outstroke and return stroke. Then return stroke with uniform velocity for next 60 degree of cam rotation. Lift or stroke of the follower is 40 mm. Base circle radius is 43 mm. And now if there is an offset which is provided on the right hand side of 12.5 mm, then how you will draw the cam profile? So
dito ang sabi, what if daw yung offset is 12.5 sa right hand side, kaya RHS, nung ating center nung cam. So, ang kanyang offset is 12.5 millimeters. Pakita natin mamaya kung paano yan.
So this is the important part in this particular case. So there are two cases. First one is that we'll draw the inline knife edge follower, the cam profile in case of inline knife edge follower, and then for the offset follower. Now the data which is given over here is outstroke is 60 degree. There is no dwell between outstroke and return stroke. So return stroke is 60 degree. Outstroke dwell is 0. Then return dwell will be 360 minus summation of this particular, but this is of no use for us while drawing the displacement as well as for the cam profile. Lift or stroke of the follower is 40 mm or 4 centimeter. Minimum radius or base circle radius is 43 mm, and offset of 12.5 mm is provided on the right hand side. Now let us choose the scale for this. So on x-axis we are having 1 centimeter is equal to 10 degree of cam rotation. On y-axis we are having 1 centimeter is equal to 10 mm of lift or stroke of the follower. Now as the outstroke is given as 60 degree, 60 divided by the scale that we have chosen is 10. So 60 divided by 10, that is 6 centimeter. So we are going to draw outstroke with 6 centimeter on the displacement diagram. Similarly, return stroke also of 60 divided by 10, that is 6 centimeter. And lift or height of the follower is 40 mm. on y-axis. So 40 divided by scale is 10 mm. So 40 divided by 10, that is 4 centimeter on y-axis. Now let us start with our displacement diagram. So first we'll draw 6 centimeter length and immediately 6 centimeter length for the return stroke, and remaining is a return dwell which is of no use. Then we'll divide this outstroke into 6 equal parts as shown over here, and return stroke also in the 6 equal part.
So again, regardless kung inline o offset yan, pareho lang yung paggawa ng cam displacement curve niya.
The lift or height of the follower is 4 centimeter as shown in the diagram. So vertical height is of 4 centimeter. Now outstroke is taking place with the uniform velocity. So we have to draw this diagonal, and return stroke is also of the uniform velocity. So mark the various parts which we have made. So we have divided outstroke into 6 equal parts. Similarly, return stroke also into 6 equal parts. Now the vertical lines, they will intersect at A, B, C, D, E and F and so on. So vertical line from 1 will intersect this red line at A, 2 will intersect this particular uniform velocity curve at point B, 3 will be intersecting at point C and so on. So all these distances, that is 1A, 2B, 3C, 4D, 5E, 6F, 7G, 8H, 9I, 10J, 11K, all these particular distances, they are important for us from drawing the cam profile point of view. So let us start with our first part, that is the first case, that is the inline knife edge follower. So we'll draw the center line as indicated over here. Then
Dito ipapakita mo na yung inline setup.
the minimum radius of 43 mm or 4.3 centimeter. Now the outstroke is of 60 degree and it is converted into 6 part on the displacement diagram. So 60 divided by 6, so 10 degree. So we'll mark the 10 degree. We'll divide the outstroke of 60 degree into 6 parts, that is 10 degree each. Similarly, return stroke is also of 60 degree. So 60 divided by 6, that is 10 degree. So total is 120 degree, that is 12 equal parts we have to make. So as you can see, we have done the 12 equal parts of 10 degree each, 60 degree for outstroke and 60 degree for the return stroke. Now we have to transfer these distances 1A, 2B. So as you can see, this is 1A, this is 2B, 3C. You can see these red lines which are appearing over here. Measure this 4D, 5E, 6F, similarly 7G, 8H, 9I, 10J and 11K, and transfer these particular lines or distances. So 1A distance is transferred over here on the first line, as you can see. Similarly 2B is transferred over here, 3C, 4D, 5E, 6F, then 6F, 7G, 8K, 8H, 9I, 10J and 11K. All these distances, they are transferred over here, and these are nothing but our A, B, C, D, E, F, G, and then we have to draw a smooth curve passing through this. So this is nothing but our cam profile in case of the inline knife edge follower. Now for the offset follower, we have to be very careful. First we'll draw the base circle of 43 mm or 4.3 centimeter. Then there is a offset of 12.5 centimeter which is provided on the right hand side. So draw a vertical line, as you can see. Wherever it cuts the base circle, from that particular point you have to join it with the center of this particular base circle. Construct a knife edge over here along with the guides. Now this is the knife edge with.
Ito na yung kinaiba niya pagka naka-offset. So from the center nung ating base circle, sukat tayo ng 12.5. Then, gagawa natin siya ng circle din. So meron tayong maliit na circle sa loob. Then, from the 12.5, gagawa tayo ng straight line pataas. Itong broken line na to, itong vertical na to. Tapos tatama siya dun sa base circle natin. Yung intersection ng base circle tsaka nitong straight line pataas, gagawa natin itong reference line. dito na ngayon magsisimula yung ating cam displacement curve. So kanina, lagi ang simula ng 0 degrees natin is itong ating nasa y-axis, itong vertical niya. So ngayon, ang 0 degrees na natin ay itong reference line na to, itong diagonal na to.
Guides, knife edge follower with the guides. Then this is the reference from which we have to mark the angles. Up till now, we are marking the angles from this particular vertical center line. This is the base circle radius of 43 mm or 4.3 centimeter. And this is the offset circle of 12.5 mm or 1.25 centimeter. Now we have to mark the angles from this. So first one is 60 degree divided by 6, that is 10 degrees. So we'll divide this 60 degree into 6 parts, that of 10 degree each. Similarly, return stroke also of 60 degree divided by 6, that is we'll divide this 60 degree into 6 equal part of 10 degree. So total will be 60 plus 60, that is 120, and 120 divided by 12, that is 10 degree. So we'll divide this into 12 parts of 10 degree each. So we'll divide this, as you can see, first 60 degree for the outstroke and remaining for the return stroke.
Nakita dito, doon na siya nagsimula sa 0 degrees. Ang 0 degrees na niya ay ito. Hindi yung nasa reference line na bago.
Now we'll mark this particular point. So one,
Dito, ito ngayon yung medyo mahirap na part na gagamitin natin itong maliit na circle na nasa loob. Tapos magagawa tayo ng tangent lines. Yung tangent line natin, patatamain natin dito sa bilog, then patatamain natin dito sa mga reference lines natin 0 hanggang 12.
1, 2, 3, 4, 5, and 6. These first 6 parts are for outstroke and remaining 6 parts from 7 to 12, they are for the return stroke. Now mark these points on the base circle and remove these particular lines. And now the most important part, we have to draw the tangent to the offset circle from this point 1. So see the tangents that we are drawing. So we have to mark the tangent from the respective point 1, 2, 3, 4, 5. So we have to draw the tangent from these points to the circle, that is this particular offset circle, like this.
Yan, yun yung tinatawag nating tangent lines. Patatamain natin doon sa circle, tapos tatama dito sa mga ginawa nating 1 to 12.
And then we have to transfer the distances, that is 1A distance we have to transfer over here, then 2B distance, then 3C, 4D, 5E, 6F, 7G, 8H, 9I, 10J, and 11K. All these distances now we have transferred over here. So measure this distance 1A, transfer it over here, correct, like that.
Then itong tangent lines na to, dito na natin ita-transfer yung mga sukat na makukuha natin sa cam displacement curve. So, kanina ay mga straight line lang galing sa center, pero ngayon dito na natin sa tangent lines ita-transfer. Tapos ita-trace na lang natin
Then
siya.
2B distance, that also we have transferred. And now draw a smooth curve passing through the points A, B, C, D, E, F, G up to K. And this is the cam profile in case of the offset knife edge follower. So in this way we can draw the cam profile in case of the offset follower. Thank you very much for
Sa design plate number 3 natin, ganyan na ipapagawa ko. Ang gagawin natin diyan, naka-roller siya. Roller follower. Tapos, naka-offset. Para mas mahirap. Okay? So, yun ang ating lecture for today. Again, we have two types, two approaches sa pag-design ng CAM. The graphical method and the analytical method. So, ito yung graphical method. Itong mga video na to, in-upload ko na sa classroom natin, tsaka yung lecture. Kaya, pwede nyo balikan bago tayo mag-finals at tsaka bago mag-design plate. So, before we go, any question from the group? Any clarification? Sa Saturday, since mag-design plate tayo, babalik ko na rin yung midterm exam nyo. So, pag binalik ko sa inyo yung midterm exam nyo, i-scan nyo, picture or photo scanner, tapos i-upload nyo dun sa classroom. Kasi yung exam na yan, hindi ko nakukunin sa inyo. So, para may kopya ako, i-scan nyo. Papasa nyo sa classroom. Pag hindi nakascan, ay hindi ko i-record yung grade. If wala na, yun lang po. Have your lunch na kung di pa kayo nagla-lunch and see you tomorrow. Bye.